All right. Good afternoon, everyone. Welcome to this session of NDA Online from ANEES classes, ADCI. We are, uh, this is the geography part of the GAT, and we were planning, we'll just continue from where we had, stopped the last time. So the last time we had discussed the Big Bang theory, the origin of the universe, the various processes in which planets and various processes, not really various, but the process in which stars and planets are formed. We had discussed a little about constellations, and we had also checked out a few theories for the origin of the Earth. Okay. Bear in mind that origin of Earth theories are only something that we have to remember by names. We do not need an explanation for it, at least at your level. When you're studying for NDA, you do not need an explanation for all of these theories. Okay. So, and then lastly, we had checked out the solar system, the placement of the planets, and the sun and the various interplanetary disks and other stuff, along with the life cycle of the sun. Okay. So remember that the sun forms a white dwarf. Please remember the end stage of the sun. Okay. It does not form a supernova, forms a white dwarf. Okay. Now, after that particular recap, today we are hopefully trying to make a comparative study of the solar system. Okay. When I say comparative study of the solar system, what we essentially mean is that we are trying to look at um, the various planets and try to see what their attributes are, what their very unique features are, and how these particular features contrast or compare with each other. Okay. Usually questions based on this are somewhat of this kind. Okay. Can you see this question? Which one of the following? This one. This was a question in the 2023 section. The April part of NDA exams. Which one of the following is the correct sequence of arrangement of the given planets in descending order of their density? Okay. So here you at least have to be aware of which is the densest planet of all, rest planet of them all, and then accordingly make a choice. Okay. So that will eliminate a few things, eliminate a few options for you. But this is usually how these questions are arranged. So when you are asked about the comparative, when we say we'll do the comparative study of planets, what we are basically looking for is all the attributes of the planet, say age-wise or density-wise, size-wise. Even it could even be the uh, how quickly they rotate, the rotational spin, the speed of rotation. So we are saying that all these different aspects of the way of various planets, of all the 8 planets, have to be compared, and usually you have to be aware of what the ascending and descending orders are. That's just one way in which UPSC quizzes you on this particular aspect. Okay. Okay. So let's look at this part. When we say we look at the planets of the solar system, we are very well aware of this particular the solar system. We had discussed that the first 4 planets, Mercury, Venus, Earth, and Mars, are called as the inner planets or the terrestrial planets. The reason why they are called as the terrestrial planets is because they resemble the Earth. Okay, they are similar to the shape structure of the Earth. All right, okay. Size wise also they are pretty similar within the same bracket. All right. Whereas opposed to that, you have 4 planets ahead of the solar asteroid belt, which are named as the Jovian planets. Okay. Now these planets are similar to Jupiter, so these are called as Jovian planets, out giant planets, gas planets. Okay. So please remember there are different ways in which you refer to these planets. Now, there are standard characteristics that help you distinguish between these 2 types of planets. Okay. The inner or the terrestrial planets have rocky surfaces. They are smaller in size. They do not come with a lot of moons, and they are denser. Okay. They are denser in general. They are denser as compared to the outer planets. Okay. Consider outer planets. The same things. Let's compare them on the same attributes. Density wise, they are rarer. In fact, Jupiter and Saturn happens to be the rarest, and Jupiter the second rarest of them all. They are larger planets. Jupiter is the largest, Saturn the second largest of the planets. So we are saying that these are large planets. Okay, they are gaseous planets. They have. Scientists consider that they have rocky cores. Their cores are probably solid and rocky. once again, there is no there is no concrete confirmation on it. Okay, so we are saying that these cores might be rocky, but the planets are made up of gases. Okay, and then the fact that these are large planets, gaseous planets, and these planets also happen to be these planets also happen because of their large masses. They also happen to rotate a little faster. Okay, so these are standard set of characteristics that are typical to a certain set of planets. Okay, so inner planets have their own characteristics and outer planets have their own characteristics. Please mark that there is an asteroid belt bang in the middle of Mars and Jupiter. Okay, now this asteroid belt is, let's consider what asteroids are. Asteroids are uh, pieces of rock. Okay, pieces of rock, usually debris of what could have been part of a planet but did not ever join the planet. We are saying that these are all remaining remnants of the solar system. Let's say they are remnants of the solar system. Okay, so these are the remaining parts of the solar system that could never successfully join a planet. All right, or become a planetoid, or then ultimately transform themselves into a planet. All right, so these are called, these all these little parts, little stones and rocks happen to be part of the asteroid belt. Okay, within the asteroid belt you also have a dwarf planet, the largest asteroid of them all, which is called as Ceres. All right, now these all these asteroids are let's say there is the one reason why these asteroids cannot be a part of some other bigger, larger planet is also because of Jupiter. Okay, Jupiter has a very huge size, and it has some bearing upon the fact that uh, you know the asteroid belt itself could never coalesce or could never separate out completely to go and be a part of the rest of the planets, because Jupiter's gravitational field kept it from doing so. Okay, because Jupiter is very huge in size, its mass itself is a indicator that the gravitational field will be very great and huge. Okay, so because of that, these asteroid belts and the rocks within the asteroids, these asteroids or rocks within the asteroid belt remained where they are because of the gravitational field of the Jupiter. All right, okay. Now, apart from that, like we said, let's discuss the let's have a comparative study of the planets. All right, let's begin with the first one. Uh, or rather, let's not go planet wise. Let's discuss aspects of the planets. Okay, let's begin with age. Let's see which planet was formed first. Okay, we have Jupiter. Jupiter was formed first, and then later on, Jupiter occupies a huge mass. Jupiter is a large planet. Jupiter is that planet which could have easily become a sun, but it did not acquire enough gases. Okay, so we are saying that Jupiter was the first planet to be formed. Slightly, there is a very slight difference in the ages of the planets, but we say Jupiter was the first one, followed by Saturn, then Uranus, then Neptune, and then all these large, huge planets took up most of the mass of the solar system. Okay, what was left behind was very little gases, and then most of the rocks and dust, which is what finally coalesced or accumulated to form the smaller inner planets. Okay, so that is why most of the mass of the solar system, especially in the planets part, in the planet section, is usually lies towards the outer planets or the Jovian planets, and then these smaller planets were formed because there was not a lot of mass or gases left to form the planets. Okay, so this is how it works. Jupiter happens to be your oldest planet, and then after that you have Saturn, Uranus, Neptune, followed by the inner planets. Okay, so this is how the planets came to be chronologically. That's how the planets came to be. Okay, let's consider the size of the planets. We've already discussed that Jupiter happens to be the largest of all planets, right? Give me a moment. Here. Okay, here we are. We say the largest of all planets here is obviously Jupiter. Okay, Jupiter happens to be the largest of all planets, and then later on you have the next planet in size is Saturn. Saturn happens to be the second largest planet, followed by Uranus and Neptune. Okay, Uranus and Neptune. So once again, the Jovian planets happen to be those which have larger sizes. Okay, now, the reason why we are going through all these sizes of the planets is because UPSC tends to ask you questions based on size, density. They have covered the comparison between planets based on size and density. Now, I don't know if they might want to do a age-wise comparison, or they might want to do a spin-wise comparison, rotational speed-wise comparison. But we'll try to study all these different aspects. Okay. So the largest planet happens to be Jupiter. We can see it over here, followed by Saturn. All right, followed by Uranus and Neptune. Okay. There is also one thing wherein you can compare the sizes in ascending or descending order for only for the inner planets as well as only for the outer planets. Okay, so within the outer planets, the size, and in generally also among all planets, the sizes go Jupiter first, followed by Saturn, then Uranus, then Neptune. Okay, for the inner planets, the sizes go Earth first, okay, because Earth is larger enough, followed by Venus, which is only slightly smaller than Earth, okay, it's almost 95% of the Earth size. So Venus is only slightly smaller, followed by Mars, which is almost half the size of the Earth, and followed by Mercury, which is about 1/3. So Mercury happens to be the smallest of all planets, and Jupiter happens to be the largest of all planets, okay. The Bear in mind that you might have to make a comparison in an ascending or descending order only for inner planets or only for outer planets also, because UPSC tends to ask you questions like that. Okay, okay. Which brings us to the next topic. If we have discussed the sizes of the various planets, then we go on to, let's say, the density of the various planets. Let's try to see if we can compare the densities. Okay. Here are the densities of various planets. Begin with the densest of all planets, that is our own very own Earth. Let's go there. Okay, can you see this? Earth has a density of 5.5. Okay, 5.5 gram per centimeter cube. So we say Earth has the highest density of them all. All right, followed by Mercury, followed by Venus. Okay, you have Earth, Mercury, then Venus, and then Mars. All right. I hope you can see those. First Earth, then Mercury. Mercury has a density of 5.4, followed by Venus with a density of 5.2, and lastly, density of Mars by 3.9, which successfully proves a point that the inner planets have greater densities than outer planets. Okay, it is the inner planets that come with larger densities, greater densities. Earth having the largest density or the greatest density of them all, followed by Mercury, Venus, and then lastly Mars. Okay. Now, after these four, you come across those planets which have you come to inner planets. Okay, let's come to the Jovian planets. Among the Jovian planets, we know that Neptune has the greatest density of it all, followed by then Uranus and Jupiter, and lastly Saturn. Okay, so the least dense planet among all the planets is actually Saturn. Please note that the density of Saturn is less than 1 gram per centimeter cube, which means its density is less than that of water. So the fact can be posed as a question in this fashion, that which among all the 8 planets might be a planet which might float on water, and which of these planets will sink. And Saturn will be the only one which will float on water because it has a density lesser than water. All right. So people. How do I see this? We have, you know all these facts together, right? Sometimes UPSC doesn't ask you a fact straight out. Sometimes it prefers to ask you facts based on, it prefers that you analyze various facts and then put all these facts together, put 2 and 2 together, and then arrive at the answer. So when you are asked a question like which planet will float on water, instead of just asking you which is the least dense planet of all, so this is the way in which questions can be posed. Okay, so please bear in mind that. Next, you come across this is the rotational spin of planets. Okay, we are trying to see their speeds. We have all agreed to the point that the planets are usually formed from a protoplanetary disk. Okay, it is usually called as a proplid. The protoplanetary. What usually happens is that the entire solar system usually begins from a nebula. The core of the nebula is where the star is formed usually, and that happens to be the largest, that happens to be most of the mass of the solar system also. Okay, like in our case, the sun has around 99.8% of the mass of the solar system. 99% of the mass of the solar system happens to be concentrated within the sun. Okay, the rest of it is all the planets. Now, that remaining portion of the nebula, which we also call as the proplid, that is where all the planets are formed. Okay, now while these planets are being formed, we have to agree that originally this nebula was a rotating mass of gas and dust. Okay, now since the nebula itself has a rotational speed, that same momentum, that same angular momentum is conserved within the planet's speed also. Okay, so because the nebula was rotating, the planets which are formed from that nebula, of part of that nebula, also find themselves in a rotation. Okay, so they also keep orbiting the sun. They also have a rotational speed. The fact that planets usually rotate because of what happens around them. There are various celestial bodies around them, and these celestial bodies usually put up are responsible for a torque. Okay, and that torque acts on these bodies, and that is why these bodies usually rotate. Okay, so most of the celestial bodies, whether the spin may be a little smaller, whether the spin may be a little greater, but they will definitely spin. Okay, you will rarely find a celestial body that doesn't spin, because that is a, how do you say it, according to physics, it's not the um, it's a very uh, rare impossibility, okay, for such a thing to happen. So we say that there is a spin. Okay, every planet usually has a spin. Does it mean that all planets have the same amount of spin? Certainly not. Okay, now that, like we discussed, the speed of rotation for a planet might depend on the fact that might depend on what sort of celestial bodies exist around that particular body, and what sort of torque they might exert upon this particular body, this particular planet, because of which its spin might alter, the rotational speed might alter. It also depends upon the gravity of the planet. Usually planets that have a larger mass also have a greater spin. Okay, because then that means that the planet tends to collapse within itself. The gravity is larger, and because of that, the planet usually, the core becomes hotter, and a hot core causes the body to spin faster. Okay, so we are saying that usually, so among these planets also, since Jupiter happens to be the largest planet of them all, you will notice that its spin speed, the rotational speed, is also faster. Okay, so now once again, these are the various speeds of the planets. Sometimes it is also an explosion that causes the planet to spin. Okay? Because of the amount of energy available, the heat available, the planet spins. Okay. Now, while we compare the rotational spin of all these planets, here's how your order goes. This is the rotational speed of Jupiter. Okay, Jupiter happens to have the largest rotational speed of them all, which means that Jupiter will usually cover its one single rotation in the fastest amount of time. Okay, so Jupiter takes around some less than 10 hours, very less than, like almost 10 hours, to finish its rotation. Okay, to finish a complete rotation around itself, because its the rotational speed is faster. Okay, followed by Saturn. Saturn also has some 36,000 kilometers per hour, which means that it takes around 10 hours 33 minutes to finish one rotation around itself. These are all days and hours and minutes are all calculated in Earth time. Okay, the time that it takes on the Earth, उस time के हिसाब से बाकी के सारे calculations किए. So we say that the rotation, according to rotational spins, according to the speeds available among the planets, it is usually Jupiter which has the fastest speed, followed by Saturn, followed by followed by Neptune, and then Uranus. Okay, first Neptune, then Uranus, followed by, and so obviously, once again, we have established a pattern that it is the outer planets that usually have a quicker or a faster rotational speed. One second, just let me take a minute to address the actual students here. If you have a question, you can ask that. This is cool. Okay, okay, fine. So we say that it is usually it is the outer planets that have fastest rotational speeds. Okay, now let's come to the inner planet. The inner planets, we say that Earth has the least it takes the least amount of time to cover or complete one entire day, and that is why its speed happens to be a little faster. Okay, after Earth, you have Mars, and then you have Mercury. So, right, first Mars, and then Mercury, and lastly Venus. Okay, Venus is a very slow planet. It takes a very long time to finish an entire rotation around itself, and that is why we say that a day on Venus is greater than a year. Okay, okay. Now that we've completed these four main aspects, the age, the size, the density, and the speeds. Okay, rotational speeds. We'll move on to each planet and try to see what unique aspects we might find about these planets. Let's begin with Mercury. Mercury happens to be the smallest of all planets. It's also the innermost of all planets. Okay. There is also a thing about the size or the atmosphere of various planets that we had to discuss. Please remember that the inner planets are closer to the sun. Okay, so they also happen to experience. They also happen to be under the influence of the solar winds. And solar winds is just a steady stream of charged particles, steady stream of charged particles coming from the sun. And that stream of particles is responsible for blowing away the atmosphere from, or gases, those extra amount of gases that the planets cannot hold on to. It tries to blow away all those extra amount of gases. Okay. Now that solar stream happens to be a little less influential when it comes to the outer planets because they are a little farther out of the path. So those planets do not usually happen to be influenced so much by the solar winds as the inner planets are. Okay, so Mercury, Venus, Earth, Mars, these happen to be influenced more. Mercury more so, even more so, because it happens to be the closest to the sun. Okay, and because of this particular reason, Mercury doesn't have an atmosphere. Okay, Mercury does not have a huge amount of size. Also, Mercury is a small planet, smallest of them all, which means that it does not have a great gravitational field. Also, okay, it does not have enough mass to have a greater gravitational field, and because it does not have a great amount of gravitational field, what happens is Mercury cannot hold on to its atmosphere. You have the solar winds which are blowing away the atmosphere of the Mercury, and Mercury, with its small size and gravitational field, not being able to hold on to it. And because of this reason, Mercury does not have an atmosphere. Okay. Since Mercury does not have an atmosphere, what happens is that that side of the Mercury which faces the sun usually becomes really hot, and the other side of Mercury which does not face the sun becomes freezing cold. Okay. So you say that on the poles, Mercury, despite being closest to the sun, also has ice. Okay. Please try to understand the contrasting conditions. We say that Mercury, despite being a planet closest to the sun, does have accumulation of ice on its poles. Okay. Now, Mercury also happens like we have just discussed, and because Mercury has freezing temperatures on one side and extremely high temperatures on the other side, the one that faces the sun, we say that Mercury also has the maximum diurnal temperature range. Okay, Mercury has the maximum diurnal temperature range, meaning that within a period of a day, the minimum and maximum temperatures that Mercury reaches has a very huge range. Okay, that difference is very high. The difference between the maximum and minimum temperatures for an entire day on Mercury. Okay, and that day, that time that Mercury takes to finish an entire rotation around itself in Earth days can be counted as 58.65 days. Okay, so it means that Mercury has a lesser speed than Earth and takes more time than the Earth to finish one entire rotation. A year Mercury takes to complete is 88 days. Okay, so when we say that it takes 88 days to complete a year, it means that Mercury is closest to the sun. So the distance that Mercury has to cover in an orbit is also lesser, which means it takes the least time to finish an entire revolution around the sun. Okay. The, when Mercury orbits the sun, it finishes that revolution in the least amount of time among among all planets in the solar system. So it has the fastest revolution or the shortest year. All right. Okay, which brings us to that uh, should be enough with Mercury. Now we move on to Venus. Venus is also coincidentally called as the evening star or the morning star. It's the brightest of all planets. It is the hottest of all planets. Venus has a reason to be the hottest of all planets. One, first of all, Venus has an atmosphere which is almost, it's many times thicker than the Earth. Okay, Venus has a 90 times thicker atmosphere than Earth, 90 times. All right, followed by the fact that Venus is completely, and that atmosphere is completely filled up with CO2, carbon dioxide. Okay, carbon dioxide is a greenhouse gas. It tends to trap heat, and that is why the atmosphere of Venus, it is the atmosphere of Venus that makes it the hottest planet. Okay, Venus also has a very interesting aspect among it. One, first of all, it has a very slow rotation. It has the slowest rotation among all the planets. Okay, so obviously, meaning it takes the largest time or the longest time to finish an entire rotation around itself. Okay, when it rotates around itself, it takes the longest time. All right. Now, also add to the fact that it takes some 257 Earth days to finish a rotation around itself, whereas it takes less than 225 days to finish a revolution around the sun. Okay, hence the contrasting fact, or the it's a paradox actually, that the Earth on Venus, a day is longer than a year. Okay, so this holds true, but it sounds weird. All right. And also the fact, add to the fact that Venus also has a different direction of spin. Okay. All the planets, like once again, to remind you of the fact that all these planets are formed from a nebula, or the remnant of the nebula after the star was formed, after the sun was formed. Okay. So all that entire nebula had a particular direction of spin. Okay. Or a direction of rotation. The planets also acquired the same direction of rotation. All these planets rotate in a counterclockwise manner. Okay, except Venus. Venus rotates in a clockwise manner. Okay, now Venus, when we say Venus rotates in a clockwise manner, we say that the thing with Venus is that, one, first of all, we have to consider the theory that we have for the different direction of spin or different direction of rotation for Venus, is that Venus had an accident. Okay, Venus went ahead, collided with another, or rather some other planet came into its orbit, crossed paths with Venus, collided with Venus, and because of that collision, Venus was set in a different direction, and it started spinning or rotating in a different direction. Okay, that is the theory we have. And so these facts together will make up Venus. Venus happens to be brightest, hottest. Please remember the reason why it happens to be the hottest of all planets, and the fact that it has a different direction of spin, and the fact that also on Venus a day is longer than a year. Okay, okay. Which brings us to Earth. We already are aware of this planet. We know this planet very well. It is known as the blue planet, the densest planet of all. It also has the presence of higher life forms. And from here begin your satellites. Okay, natural satellites start from this part. The first two planets did not have natural satellites. We have natural satellites from the Earth. Okay, Earth has one natural satellite, that is the Moon. We've already discussed how the Moon came to be formed. All right, which brings us to the next planet, Mars. Mars is known as the red planet. We know that Mars is famous because its day is approximately equal to that of the Earth. Okay, it's slightly longer by a few hours than the day on Earth, but Mars has a day which is approximately of the same time as that of the Earth. Okay, Mars is also famous for the fact that it has the largest volcano within the solar system. Okay, that volcano is known as Olympus Mons. It's a dormant volcano. Formerly, it used to be known as the Nix Olympia, but this is the volcano. And it also has two natural satellites called as Phobos and Deimos. All right, which brings us to the outer planets, and now you come to Jupiter. Okay, Jupiter happens to be the largest of all planets. We are also aware that it has a small red spot on it. Okay, not a small red spot, it's in fact a great red spot. Okay, it's a thunderstorm brewing on Jupiter. But you can see it's pretty visible. It is not to the naked eye, but if you see it through a telescope, it's properly visible, the great red spot. And Jupiter happens to have the fastest day, or the quickest day, or the shortest day, and the fastest rotation. The day is around 9.8 hours. Once again, we've already discussed the size of Jupiter is too huge. It's a massive planet with less density, and that is the reason why Jupiter usually rotates faster. Okay, Jupiter also has 95 satellites, Ganymede being the largest among them all, and in generally also not only among Jupiter, it happens to be the largest among all satellites also. Ganymede and Titan, the satellite from Saturn, these are so large that they are even larger than a few planets in the solar system. Okay, so they are large satellites, which finally brings us to Saturn. Okay, Saturn happens to be the second largest of all planets. It also happens to be the least dense among them all. There is a very unique feature about Saturn. Um, let's discuss a very common aspect about the four Jovian planets, that all of them have rings. Okay, they have a ring structure. Now these rings, the rings of Saturn are pretty notable. They're really beautiful. They have been talked about so much, and until the 90s, I think 70s, I think we were of the opinion that apart from Saturn, no other planet had rings. Okay, but then we discovered that almost all the Jovian planets have rings, of course, and those rings are actually they are also just pieces of gas and dust and rock and ice mostly. And that is because these are, once again, because of their massive size, they tend to keep little celestial objects, smaller celestial objects within their gravitational field. The ring structure these rings, the structure of these rings comes to be formed from this aspect, comes from this fact. Okay. So it's because of the gravitational field that it keeps attracting these little pieces, little celestial objects towards itself and keeps them in that ring structure. Okay. So Saturn has those beautiful 8 rings, 9 ring structure. Saturn also happens to have the largest number of satellites, which is 146 in number. Okay. 146 proven satellites with orbits. We are not counting those that there are multiple other satellites, but we are not counting those that do not have orbits. Okay. Confirmed orbits नहीं है जिनके, वो नहीं count कर रहे. So this is the official number for satellites of Saturn. Okay. But in general, Saturn will have the largest satellites of them all. Greatest number of satellites among them all. Which brings us to Uranus. Uranus is known as the green planet. It is because it has a lot of methane within its atmosphere. Okay. It is also, okay. Uranus is also that planet that does not exactly rotate in a counterclockwise manner. Okay. This is what we are looking at. We are looking at the tilts of the various planets. Okay. All of these planets have different amounts of tilts. Okay. Now these tilts are determined by originally we believe that when the planets were formed, all of them must have been pretty straight. Okay. They must not have been tilted. Most of them were just, with their equators were almost parallel to that of the orbit of the Earth, orbit of the Sun. Okay. The orbit, the elliptical orbit, that is what we believe. All right. But then what has happened is, after a while, because of various events happening around there in the vicinity of these planets, they acquired these tilts. Okay. These planets acquired these tilts. So Mercury almost has no tilt. If you can see Mercury properly, no, not a tilt. Give me a moment. Okay, no worries. We were at Mercury. Okay, we were saying look at Mercury. Mercury does not have a tilt at all. Okay, the tilt is very, very negligible. Not that Mercury doesn't have a tilt, it tilts very slightly, but the tilt is less than 1 degree. Okay, so it's almost a negligible tilt. Okay, which brings us to, let's say, another planet that doesn't tilt at all is Jupiter. Jupiter has, once again, a very little amount of tilt. Okay, 3 degrees. 3 degrees is not a good amount of tilt. Okay. Then next you come to Earth. Okay. Earth has 23.4 degrees of tilt. Okay. So once again, you see there is a good amount of tilt over there. Okay. Comparable tilts are those of Neptune, Mars and Saturn. Okay. ये सारे जो है, ये सारे comparable tilts है. Okay. 23, 25, 26 के आसपास, 28 के आसपास होने वाले. Now you come to two major tilts. One is Venus and the other is Uranus. Okay. Both these planets famously known not to follow the same counterclockwise rotation that the rest of the planets follow. All right. So we say among all the 8 planets, the six of them, apart from Venus and Uranus, follow a proper counterclockwise rotation. Okay. But Uranus and Venus do not follow that. All right. Now the thing with Uranus is that Uranus actually has a tilt of around 98 degrees Celsius. Okay. 98 degrees Celsius meaning if this was the erect position, if this is the erect position, then Uranus is lying like this. Okay. Uranus is lying on its side. Nee, I confirmed it on the things. So Uranus is lying on its side. Now let me give you a picture which might help you see what is happening with this is what is happening with Uranus and Venus. Okay. We say if this is the most erect of all positions. Okay. And if this is the position of the Earth, okay, it's slightly tilted, 23.5 degrees to the vertical, slightly tilted. Okay. This is Venus. This is Venus's position. We say that, sorry, this is Uranus's position because it has more than 90 degrees of tilt. Okay. So it's almost 98 degrees tilted. So whenever Venus rotates, when the rest of the planets rotate in this fashion, if this is the fashion in which the rest of the planets rotate, at that time, Uranus tends to rotate like this. Okay. It tends to rotate in this fashion. All right. So it feels like Uranus is rotating on its side. Okay, it's just rolling on its side. That is what Uranus feels like. Half of the time, it feels like Uranus is performing cartwheels of some sort. Okay, so this is the problem with Uranus. The once again, this is also attributed to some sort of accident it might have had, just like Venus had with some other planet or some other celestial body, larger celestial body, maybe an asteroid also. Okay, so we say that this probably Uranus also probably encountered some sort of an accident. It probably collided with some other asteroid or planet, and on account of that, it became tilted in this fashion. Okay, it acquired this amount of tilt. The next planet in case is Venus. Look at the tilt that it has. The tilt is almost 177 degrees Celsius, meaning close to 180. Okay. So if this is the position of the planet, if this is the erect position of the planet, if this is the erect position of the planet, how Venus really works is like this. Okay. This is really how Venus is working. Meaning its north pole is actually facing downwards, its south pole is actually facing upwards. Okay. So Venus उल्टा हो गया है, let's say very normally, and उसकी वजह से उसके यहाँ पे दिन भी उल्टा पुल्टा चलता है. We say on Venus the sun rises in the west and sets in the east. Okay, this is Venus for you. All right, and now you understand why, because the tilts work differently, the spins work, the direction of the spin works differently. All right. The thing with Uranus is also, while we are discussing Uranus, because it is so inclined, उसका inclination इतना ज़्यादा है. So the place where the latitudes where Uranus actually receives the direct rays of the sun is different, and the difference between the daylight and nighttime on Venus happens to be a large difference. Okay, so in terms of Earth years, Uranus usually undergoes 42 years of daylight, Earth years of daylight, and 42 Earth years of nighttime at a given point of time. Okay, so once again, the difference between the daytime and the nighttime is greater. Okay, it's larger. Fine. Like we discussed, so like all these planets have a ring structure. The Jovian planets all have a ring structure. Uranus also has a ring structure, and Uranus comes with 27 satellites, the lowest recorded temperature among all planets also. Okay. Now, ideally, Uranus should not have the lowest temperature. Neptune should have the lowest temperature because it happens to lie farthest away from the sun among all the planets. Okay, so Neptune does have the average lowest temperature among all the planets, but Uranus happens to have the lowest recorded one. Okay, Neptune also happens to have a green spot on it. Neptune also happens to have a very small amount of day. Like we discussed, the spin speeds are faster, so the time to complete an entire rotation around itself will be lesser. Okay. Meanwhile, Neptune also happens to lie the farthest among the solar system from the sun. So the period of revolution of Neptune will be the greatest. It will have the longest revolution in the solar system, and hence the longest year also, which is 165 Earth years. Okay. Uh, these are all the planets together. Okay. This is study of all the planets. Give me a minute and we'll resume once again. Okay, so we discussed the geologic timescale. Okay, if we are good with the planets and the planets of the solar system, then we'll discuss the geological timescale. Okay, so here we are looking at the Earth's history in terms of time. Okay, we are looking at how the Earth progressed and evolved during various time periods. Okay, and these are those various time periods. The largest of them all is called as eons. Uh, then eons are divided into multiple eras, and multiple eras get divided. An era gets divided into multiple periods, and a period gets divided into multiple epochs. Okay. Now here we are. This part, the one before the Cambrian period, is usually called as the Precambrian period. Okay, so we refer to all these older eons like Hadean, Archean, Proterozoic. We refer to all that entire period in general as a block, and en bloc as Precambrian period. Okay, something that happened before the Cambrian period. So Precambrian period is usually about during that period you had the invertebrates and all coming up, lower life forms. All right, it is that period. Then it is during the Cambrian period that you came across vertebrates. Usually, vertebrates started from this point. Ordovician was this is where initially all the mountains on the earth started building up. Okay, Silurian periods is famous for the fact that and this in this period you had the plants on land for the first time. Okay, Devonian was famous for fishes and amphibians and other types of organisms evolving themselves. Carboniferous period, like the name suggests, is a period for coal formation. Okay, we still try to use the coal that was formed during the Carboniferous period. Okay, this is the coal formation period. This is also the period where reptiles came to be. They started they originated, reptiles originated during this period. Okay, Permian period is very famous for increased climatic variations. Here you saw multiple climatic variations. So you saw the climate started to change rapidly during this period, and now since there were different climatic types, you also saw an increase in the species of the animals, okay, or living beings. So you had more insects, more animals in general. Triassic period is mammals on land. Jurassic period is famous for flowering plants also because during this period, during Triassic and Jurassic period, you also have dinosaurs being a dominant species. Okay. Cretaceous periods are famously known for the beginning of the Alpine mountain system. Okay. The Alpine mountain system that we know of, the Alps, the Himalayas, Rockies, and Andes, this is the Alpine mountain system. Okay. So we say that this is the initiation period. The Cretaceous period is the initiation period. Cretaceous period from the Indian context is also important because the Deccan lava flows happen to belong to this period. Okay, the Cretaceous period. Eocene. Now you move on to this part. Okay, the Cenozoic era. We are already done with the Paleozoic and the Mesozoic era. Move on to the Cenozoic era. The epoch is important. During the Eocene epoch, Himalayas started building themselves. This is the initiation period of the Himalayas. Okay, so this is an important part. In the Oligocene period, Oligocene epoch is famous for the fact that the apes originated, and the Alp mountains were also initiated, and also like we say, grasslands started expanding themselves. Okay, Miocene is famous because penguins came to be. Pliocene is famous because Shivalik range came to be. Okay, Pleistocene and Holocene. Now these are the two most recent epochs for this particular period, quaternary period. The last period or the most recent period being quaternary period, and Pleistocene and Holocene being the recent of the epochs. Holocene being the most recent one. We are currently living within the Holocene epoch. Okay, so Pleistocene epoch is important because you saw multiple glacial and interglacial periods. If you've seen Ice Age, and I think that is a movie most of you must have seen. If not, personal recommendation, please go see the movie. Okay, you have to understand that the earth went through a period of complete glaciation. Okay, so everything on the earth started to become colder, 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 so cold that the entire earth froze up. Not the entire earth, but major chunks of the earth froze up. Okay, and it was covered with ice. That is called as an ice age. Okay, or a glaciation period where everything, most of the part of the earth is covered by ice. Okay, and then it is usually followed up by a interglacial period wherein the earth starts to warm a little. Okay, and because of that the ice starts to melt. Okay, so it went during this Pleistocene age, both Europe and Americas, because we are considering these two major landforms or continents, they went through major glaciations. Okay, four glacial periods and three interglacial periods between them. So once again, please try to understand that when the earth goes through all this glaciation and interglacial periods, it is going to all these glacial topographic features that we know of, like the Great Lakes, or uh, let's say the fjords of Norwegian coast and all, they were all formed during this period. Okay, um, now that we are armed with this particular knowledge, uh, let's say you were asked to, um, okay, let's say you were asked to um, arrange in a chronological fashion or in the beginning or in the order of their formation few geological features in the world. Okay, so it now you may have an option of the Great Lakes, Himalayas, Alps, and say the Deccan lava flows. Okay, can you try to arrange those? We have the Himalayas, the Deccan lava flows, the Great Lakes, and the Alps. Which ones came first? Which ones came later? Wo- Would you like to answer? Take a guess. We can always take a guess. Which of these features came first? Himalayas, Alps, Great Lakes, and lastly the Deccan Traps. Which of these came first and which of these came? सबसे पहले क्या आया होगा? रिपीट करूं? वो हिमालयाज, एल्प्स, वो देखिए वहां पे टेक्स्ट में है हिमालयाज, एल्प्स, ग्रेट लेक्स एंड डेक्कन ट्रैप्स यहाँ पे सबसे पहले एल्प्स आए होंगे. ओके, फिर ग्रेट लेक्स, देन हिमालयाज, हिमालयाज के बाद डेक्कन ट्रैप्स आए. नहीं, यू यू बिगिन विद डेक्कन ट्रैप्स. क्रेटेशियस से शुरू करते हैं पहले. सो डेक्कन ट्रैप्स आए पहले. दीज आर द पेनिनसुलर प्लेटो ना, ओल्डेस्ट थिंग आल्सो ऑन द इंडियन यू नो स्ट्रक्चर. डेक्कन ट्रैप्स पहले आते हैं, क्रेटेशियस के हैं. फिर उसके बाद हम कहते हैं हिमालयाज आए. ओके, उसके बाद बने एल्प्स एंड देन लास्टली ग्रेट लेक्स बने, बिकॉज ग्रेट लेक्स विल हैव हैपेंड इन द द ग्लेशिएशन इंटरग्लेशिएशन पीरियड. तो ग्रेट लेक सबसे आखिरी होंगे इस लिस्ट में. ओके, वंस अगेन ये वाला जो क्वेश्चन होता है दिस विल बी कंसिडर्ड अ टफर क्वेश्चन. ओके, यूजुअली आपको इतना टफ क्वेश्चन नहीं आएगा बेस्ड ऑन दिस फैक्ट. ये वाले टेबल, ये जो टेबल आपको बोर्ड पे दिखाई दे रहा है उस पे आपको क्वेश्चन पूछा गया था कि अभी का जो फिलहाल लेटेस्ट ये चल रहा है अपना पीरियड चल रहा है उसके एपॉक्स कौन से है. ओके, so you were supposed to know the last two options, Holocene and Pleistocene. You were supposed to know these two options. Okay, कि आपको ये दोनों चीजें पता होनी चाहिए थी कि हम फिलहाल कौन से पीरियड में जी रहे हैं एंड हमारा ये लेटेस्ट एपॉक्स कौन से चल रहा है, ये या उसके दो एपॉक्स कौन से होते हैं. ओके, तो ये वाला जो ये होता है, ये जो अभी मैंने क्वेश्चन आपको प्रेजेंट किया है हिमालयाज, एल्प्स, ग्रेट लेक्स एंड डेक्कन ट्रैप्स का, उसके बेसिस पे आप यूजुअली दिस इज अ ये दिस इज टेकिंग अप्लाइंग फैक्ट्स अ लिटिल टू मच. ओके, मतलब बहुत ही ज्यादा इलेबोरेट तरीके से आप फैक्ट्स को अप्लाई कर रहे हैं. ये बहुत ही बहुत डिडक्शन वाला क्वेश्चन है. आपको तीन चार फैक्ट्स को एंड तीन चार चीजों को जोड़ के इसको आंसर बनाना पड़ता है. ओके, सो इस बट देन वंस अगेन आई एम नॉट पुटिंग एनीथिंग पास्ट यूपीएससी. सो इस तरह के क्वेश्चंस एक्सपेक्ट कीजिएगा बिकॉज यूपीएससी टेंड्स टू आस्क यू सच क्वेश्चंस. ओके, आर वी गुड पीपल? ओके, यार दिस इज न्यू टू मी. ओके, ठीक है, चलेगा. which brings us to, wait a second ना. Okay, give me a minute then. This is the question. In terms of geological time scale, the quaternary period consists of two epochs. Which were the two epochs that we were talking about? ये रहे आपके आंसर्स, प्लेस्टोसीन प्लायोसीन, होलोसीन प्लेस्टोसीन, प्लेस्टोसीन मायोसीन एंड होलोसीन ईओसीन। नहीं हमको लास्ट टू चाहिए, कौन से है ये? होलोसीन प्लेस्टोसीन, वी वर लुकिंग एट दीज टू। ओके, हमको चाहिए होलोसीन एंड प्लेस्टोसीन। ऑलराइट, ठीक है, दीज आर द टू वंस। या फिर ये अभी जो हम प्लैनेट्स को डिस्कस कर रहे थे, तो ये उनका डेंसिटी होता है। डेंसिटी के हिसाब से अगर प्लैनेट्स को अरेंज करना हो तो कौन सा वाला सबसे बेस्ट ऑप्शन है इसमें से? डिसेंडिंग ऑर्डर ऑफ द डेंसिटीज, मीनिंग आपको सबसे ज्यादा डेंस जो प्लैनेट होगा वहां से शुरू करना पड़ेगा। विच इज द डेंसेस्ट ऑफ ऑल दीज प्लैनेट्स? सारे प्लैनेट्स में सबसे डेंस कौन सा होता है? अर्थ। तो एनीथिंग लीडिंग विद अर्थ इज गोइंग टू बी योर ऑप्शन। ओके, देन उसके बाद सबसे लीस्ट डेंसिटी कौन से प्लैनेट का होता है? सैटर्न। सैटर्न का डेंसिटी सबसे कम होता है। तो अर्थ से शुरू होकर सैटर्न पे एंड होने वाला जो भी ऑप्शन है वो ऑप्शन आपके। तो ए एंड सी दोनों चलेगा, सी भी है, सी में भी ये है। तो अभी बताइए इसमें जुपिटर एंड वीनस का प्लेसमेंट कैसे होना चाहिए? किसकी डेंसिटी ज्यादा है? वीनस की डेंसिटी ज्यादा, सो अर्थ के बाद वीनस आएगा, वीनस के बाद जुपिटर, जुपिटर के बाद सैटर्न, सो ऑप्शन सी। ओके, दैट इज गोइंग टू बी योर ऑप्शन। दिस तो यू जस्ट डिस्कस्ड राइट? अभी अभी 1 घंटा पहले भी डिस्कस कि प्राइम मेरिडियन कहाँ से पास नहीं करता है, थ्रू विच ऑफ दीज अफ्रीकन कंट्रीज डज इट नॉट पास? विच इज दैट? मोरक्को। इट वोंट पास थ्रू मोरक्को, इट विल पास थ्रू अल्जीरिया, माली एंड घाना। ओके, certainly pass through these three. Once again, this one, which among the following planets is the largest in size? This is also something we just discussed. Earth, Venus, Mars, Mercury. अर्थ। टेरेस्ट्रियल प्लैनेट्स में अर्थ का साइज सबसे बड़ा, फॉलोड बाय Venus, which is 95% of Earth's mass, followed by Mars, which is half of Earth का size, followed by Mercury, जो Earth का भी 1/3 है। ओके, तो Mercury वैसे भी सबसे छोटा है, and among the terrestrial planets, Earth happens to be the largest of them all. ओके, सो ये कनेक्शन, ये है आपका। ये वाला बताइए, क्वेश्चन नंबर 120, which of the following planets has the highest density? मर्क्यूरी, वीनस, जुपिटर, अर्थ। सबसे ज्यादा डेंसिटी कौन से प्लैनेट्स का होता है? प्लैनेट का होता है अर्थ का। एब्सोल्युटली, अर्थ का डेंसिटी सबसे ज्यादा। ओके, और फिर उसके बाद किसका डेंसिटी है? सबसे लीस्ट डेंसिटी क्या कौन सा है इसमें से? जुपिटर। जुपिटर का डेंसिटी उसमें से लीस्ट होगा। हो गया सर, आई एम डन।